Howdy, 8th grade. Today we are going to talk about how to solve some radical expressions. It's the same process we've used for a lot of other things, so this is probably going to sound very, very familiar, but that is okay. That's probably actually a good thing. So what a radical expression looks like is it is an expression, obviously, with a variable inside a radical. So obviously it's an expression with a radical, but that doesn't really matter unless we've got a variable inside the radical to play with. And that's what's going to make these a little bit more interesting to solve. So I want us to think about this very similarly to how we solved our equations where we had things like, let's review, something that looked like x plus 2 squared plus 7 equals, let's make that 12. And the way we would solve this is we would get our exponent alone first, because otherwise we couldn't really get rid of it. It's very difficult to square root the whole thing, and since we do all our operations to an entire side, how we would solve this is step 1 would be to isolate the exponent, then to square root our exponent away, and then to solve like normal. So now we're just doing that, but backwards. So now we don't have an exponent to isolate. What we do have is a radical. So the first thing we want to do is to isolate the radical. Because if we don't get it by itself, there's absolutely nothing we can do with it. So we need to get it by itself. Then we're going to square both sides. And then we're going to solve using the same old tricks we've been using since the very beginning of the year. So let's look at an example real quick. This is going to be a pretty easy example, but if I have the square root of x plus 7 equals 15, what I'm going to want to do is to isolate the radical. I've got my radical here, so I need to get rid of the 7. It's being added, so I'll subtract it to get rid of it, and I end up with the square root of x equals 15 minus 7, which is 8. And just like that, I have my radical isolated. Now I need to square both sides. So I'm going to square this side and square that side. And the square root of x squared is x, because that's what the square root means. And that's going to be equal to 8 squared, which is 64. And just like that, now technically I would need to solve it, but lucky for us, it's already solved. So we are good to go. That makes me happy. But that was a pretty easy one. I want us to try one that's maybe a little bit more difficult. So what happens if I have the square root of 3x minus 2 plus 7 equals 23? There we go. So what I want to do is first I want to isolate my radical. And again, all I have to do here to isolate this radical is to get rid of what's not the radical, which in this case is the 7. So I'm going to end up with the square root of 3x minus 2 equals 23 minus 7 is 16. Now what I want to do is to square both sides. So I'm going to square this side and square this side. A square root squared just leaves what's on the inside, and that's going to give me 3x minus 2 equals, and on the other side I have 16 squared, which should be 256, I believe. Sounds right. So now I just need to solve this equation. I'm going to do that is I need to get x by itself. So I need to get rid of the 2 by adding 2 to both sides. I'll have 3x equals 258. Good news, this number is divisible by 3. That's nice. So x is going to equal whatever 258 divided by 3 is, which I believe is going to be 86. Yes, 86 looks correct. So that would be x. I want to give you guys one more problem. So if I have 5 minus 2 times the square root of 3x plus 3 equals 1. How would I solve this? Well, first I want to isolate my square root. And the way I'm going to do that is I need to get rid of this 5 first. So I'm going to subtract 5 from both sides. And these 5's cancel out, and I end up with negative 2 square root of 3x plus 3 equals negative 4. Now I have this negative 2 out front that's multiplying, so I need to divide by negative 2. Do that to both sides. I'll end up with the square root of 3x plus 3 equals 2. And now that this is all isolated here, I can square it. So let's square both sides. And I'll get 3x plus 3 equals 4. I can subtract 3 from both sides to get the 3x by itself. And dividing by 3, I get x equals 1/3. And just like that, we're done. So hopefully the steps we used to solve this seemed very familiar. Our goal was to get things alone so we could do the inverse operation, the opposite thing. In this case, we're using square roots, so the opposite thing was squaring. And then after we did that, we just solved like we normally do, and we're done with the problem. I will see y'all tomorrow. Have a great day.